Okay, so question number 22 from here. Today is the class for past papers of trigonometry. We have done the algebraic part of the trigonometry, solving trigonometric equations. The next thing we will do after today's class is the graphs and the transformation and the trigonometric graphs. But that is the work for the next class. Right now we are doing some past papers so that you can also try them later on till the next class and bring in your questions. So the first part you can see always you will see most of the questions are like this. The first part will be to show the prove the identity, and then the second part they will use the identity that you have proved in the first part and then simplify your things further, get the answer. So in the first part, I told you if I'm doing this past paper and in my exam, in my CI exam, what I would do, what I did in my time was I would substitute let s is equals to sine theta, c is equals to cos theta, and t is equals to tan theta. When I did this, now I can simplify and I can write everything shorter. Sine cube, so this would be sine cube upon sine minus 1 minus sine square upon 1 plus sine is equals to, or this is similar to minus tan square 1 plus sine square. And now we would do the working on either one of the side, or you can do the working on both sides, and wherever you can show that the left side is equal to the right side, you will stop your working and that's it. That's the solution. You have shown it. So mostly you work on the part, you try to find the more complicated part and then you work on that complicated part and then try to change it to the other form. So on the left side you can take the LCM. So if you take the LCM, you will multiply this thing with 1 plus sign and this thing as well with 1 plus sign, and this would multiply with sine minus 1, and this can also will also be multiplied with sine minus 1. So when you do this, your denominator becomes sine minus 1, and 1 plus sine can be written down as sine plus 1. It's the same thing, 1 plus sine or sine plus 1. In the numerator, this would be sine cube plus sine power 4 minus sine cube, and minus sine square minus 1 would be plus sine square. So you can see the sine cube and sine cube cancel out. So you have sine 4 plus sine square upon, in the denominator you can apply the third identity, a plus b, a minus b. This would become a square minus b square. So sine square minus 1 square. Further you can take sine square common in the numerator. So this would become sine square plus 1 divided by sine square minus 1. This would become what? You have the identity. You can see you have a tan over here. Look, negative tan square. So if you had cos square in the denominator, that will help you to change the sine square upon cos square would become tan square. So the first identity is sine cos square plus sine square is equals to 1. So sine square minus 1. So sine square minus 1 will be equal to minus cos square. If you move the cos on the right side and 1 on the left side. So sine square minus 1 is minus cos square. So you can replace the sine square minus 1 and minus cos square. And sine square upon cos square will be tan square and minus tan square, and this would become sine square plus 1. And you can see on the right side as well you have the same thing, minus tan square 1 plus sine square, or sine square plus 1 is the same thing. So you have shown, hence proved. This is your 4 marks. Then the next part, they are asking you to solve this now. Solve the equation. So whatever that you have proved over here, this thing, you can replace it with this part. So this means this complete thing I can replace with minus tan square 1 plus sine square. So in part B, minus tan square 1 plus sine square is equals to, the equation is tan square and 1 minus sine square. And you want to solve this from 0 till 2 pi. Okay. Now you want the all solution. You actually want all solution. If even you don't give one of the solution, your marks will be deducted. So we have to make sure that we get all of the solutions. So what I can do, what I think right now, if I can cancel out this tan square and tan square, but I am not cancelling this out. right now. You'll see why. If I move everything on one side, this would become tan square 1 minus sine square and plus tan square 1 plus sine square. So what would this be? Now you can take tan square common. So you will have 1 minus sine square plus 1 plus sine square. So sine square cancel out. Subtract minus sine square plus sine square. So you will have 2 tan square theta. Sorry, not theta. 0 is equal to 0. So 0 upon 2 is equals to tan square. So this means that your tan square theta is equals to 0. So tan theta will be equal to theta 0. Square root of 0 is again 0. So tan is 0 when, if you look at the graph of tan, right now we have not done graphs, okay, but I will tell you the graph of tan something looks like this. It is 0 at tan is 0 at 0, and then tan is 0 at 180, and then tan is 0 at, you can use a calculator as well. Tan 0 is 0, look, then tan 180 is 0, and tan 360 is also 0. Right now it is in radians, so it would be pi by 2 and pi. Oh, sorry, pi and 2 pi. But right now the region is between 0 and pi by 2. So pi by 2, sorry, between 0 and 2 pi. So 2 pi and 0, they are not within the range. So the only solution is pi. This will be your answer. Okay? Any questions, anyone? Anything?
सर बी पार्ट दोबारा समझा दें
Mm-hmm. The second part, you understood why I replaced this thing with this?
ये तो समझ आ गया लेकिन सिंपलीफाई कैसे किया
Simplification. There are many ways to simplify. I try to not cancel out thing directly because that would lead to, look, your, if you would have cancelled this out, you won't have gotten anything out of it. 1 plus sine square is equals to 1 minus sine square. Sorry. This is minus. If you would have cancelled this thing like this, so your equation would have no solutions. That's why always try to keep things as it is, that I, and try to simplify without cancelling out, and then see if you get any other solutions as well. So when I move this complete bracket on the right side, this became positive tan square and 1 plus sine square. And then I tried to simplify this further. So I saw that I can take t square common. T square and t square. So t square taken common, I get 1 minus sine square, which is from this bracket, and 1 plus sine square, which is from this bracket. So plus sine square minus sine square cancel out, and 1 plus 1 is 2. So you are left off with 2 tan square is equals to 0. The 2 went on the other side and divided. So 0 divided by 2 is 0. So tan square theta is 0. And you will move the square root on the other side, which is again 0. So tan is 0 at 0, pi, and 2 pi. This is something I'll explain it to you later when we'll do the graphs. I'll show it to you, the exact solutions. But right now you need to just know this, that tan is 0 at 0, pi, 2 pi, then 3 pi, then 4 pi, then 5 pi. Multiples of pi. The tan is 0 is multiples of pi. And then you can see 0 and 2 pi are not included. So that's why I have neglected those. I have ignored those, and I have got only one solution. Theta is pi. Okay, so you have, okay, right now again we are trying to simplify things. First of all, I cannot directly do the cos inverse, and is equals to 7 minus 3 upon cos theta from minus 90 till 90. So first I will have to simplify things, move things around, and make cos theta the subject, so that I can move it on the other side, become, find the alpha, and then do the quadrant things and everything. So for the simplification, I'm again doing let c is equals to cos theta. So I will write 2c 7 minus 3 upon c. Now you can take the LCM on the right side. So 7c minus 3 upon c is 2c. So c would go over there and multiply. So you will have 2c square is equals to 7c minus 3. Move everything on one side. So 2c square minus 7c plus 3. Now this is quadratic equation, disguised quadratic. So you will solve it the usual way, the quadratic equation, minus 7 plus 3. So cos theta, one of the solutions for cos theta is 0.5 and the other one is 3. Now you will find alpha for both of them. So cos inverse of this 0.5 and cos inverse of 3. You won't get any solution for the second one. Cos inverse of 0.5, 60. And cos inverse of 3, you won't get any answer. Look, it is an, what do you say, imaginary 0 minus 100 iota. You will learn what is this, but your calculator won't give you any answer. So no solution over here. Now you will place this alpha in the coordinates where your cos is positive. You can see it is positive 0.5. And you have negative angle as well within the range. Look, from minus 90 till 100. So you can move positive 90 and negative 90. And your alpha, you will place it in the coordinates in your where cos is positive. So cos is positive over here as well, cos is positive over here as well. So in the first quadrant, your theta is the same as your alpha. And if you move in the negative angles, your theta will be negative alpha because you are moving now clockwise. So this means you have two solutions. Your theta is negative 60 and positive 60 both, because you can also move in the clockwise direction because of the range that they have given you. Okay, this is your 4 marks. Any questions, anyone? Now you have sine 2 theta, cos 2 theta. So this is the one which I was telling you about, when you have to change the range, amend your range slightly. So in this one you have 2 sine square 2 theta, sorry 3 sine square 2 theta plus 8 cos 2 theta is equals to 0. So the problem is you have sine over here, you have cos over here. So you have to somehow use the identities and then bring it into any one of them, which I can see we have cos square plus sine square is equals to 1. So sine square I can replace it with 1 minus cos square. So this means 3 sine square 2 theta I can replace it with 1 minus cos square 2 theta plus 8 cos 2 theta is equals to 0. I replace the sine because now I will have a complete quadratic, disguised quadratic in terms of cos. So now you will expand this 3 minus 3 cos square 2 theta plus 8 cos 2 theta equals 0. So minus 3 cos square 2 theta plus 8 cos 2 theta plus 3. And you can see this is again disguised quadratic. And you will get two solutions for cos 2 theta. Minus 3, 8, 3. So your solution for cos 2 theta is coming out as 3 and cos 2 theta is negative 1 upon 3. Now you would find alpha. Alpha again cos inverse of negative of 3, you won't get any solution, no solution. Over here you will get an alpha. So alpha is cos inverse of 1 upon 3. You don't take the negative sign. Don't forget. 70.5. And now the problem is you don't have theta only, you have cos 2 theta. And the range is for theta. So now you will amend your range. You will multiply the complete range with 2. So 0, 2 theta, 360. Now I will solve. I will find the solutions for 2 theta between 0 and 360. So your cos is negative. So cos is negative in the second, and the third. In the second quadrant, your solutions will be of 2 theta, not theta. The second quadrant will be 180 minus 70.5. And then in the in the second quadrant, yes, 180 minus 70.5. Third quadrant, 180 plus 70.5. And then for theta, you will divide it, both of the solutions, by 2. So 180 minus 70.5 divided by 2, 54.8. And this one, 180 plus 70.5 divided by 2. Oh, sorry. 125.3. These are the two solutions. And you can see these two solutions are within 0 and 180. Find the possible values of x for which part A, sine inverse of x square minus 1, it is equals to pi by 3. Give me your answer correct to 3 decimal places. So this is simple. It looks a bit unique, but when you move the sine inverse on the other side, it would become simple sine. So x square minus 1 is equals to sine of pi by 3. So sine of pi by 3 is root 3 by 2. Root 3 by 2. So x square minus 1 is equals to root 3 by 2. And then x square will be equal to root 3 by 2 plus 1, right? Plus 1. This would be root 3 by 2 plus 1. And then correct to 3 sign. So now you will move the square on the side. So plus minus square root of this complete thing. So this answer is square root of this answer. Sorry, not square root. 1 point positive and negative 1.366. This is it. Three marks. Then part B. Sine 2 theta plus pi by 3. It is equals to half. First, you will have to amend your range. Your range is from 0 till pi. So to make the range 2 theta plus pi by 3, you multiply complete thing by 2 first. So 0, 0, 2 theta, 2 pi, and then plus pi by 3. So pi by 3, 2 theta, and 2 theta plus pi by 3. This is the range within which your solutions you will find. And then you will find your alpha over here. Alpha will be sine inverse of half, which will be pi by 6. I think, yes, pi by 6. And so now you will place this in the quadrants where your sine is positive. And you know that your sine is positive in the first and the second quadrant. Pi by 6 and pi by 6. This is your alpha. And the range, look at the range. It is from pi by 3. Pi by 3 is 60. And pi by 6, it is equal to 30. So the first solution is not part of the solution. The first answer is not part of the solution because it is starting from 60 till 360 plus 60 is 420. It is 60 till 420. It is somehow degrees. But the first answer that we're getting, it is 30 degrees or pi by 6. So you will look at the second answer. The second answer is part of the solution. So 2 theta plus pi by 3, it is equals to pi minus pi by 6, the first solution. and then you can rotate it once more like this. So that will be 360, which is 2 pi plus pi by 6. And then they want the exact answer. Oh, look, theta in terms of pi. So they want the exact answer. So 2 pi plus pi by 6 minus pi by 3. First of all, pi, use your calculator. Okay, use your calculator. Pi, what happened? Pi minus pi by 6. This will be 5 pi by 6. And this thing would be subtracted, minus pi by 3, minus pi by 3, pi by 2. And then divided by 2. This answer divided by 2. So the first answer of theta is pi by 4. And the second answer is 2 pi plus pi by 6 minus pi by 3 and then divide by 2. So 11 pi by 12. These are the two solutions. Okay.